All right, let's have a look at the first question over here. We are looking at, for the function with the rule 2x plus 5. The reason why it's an f of x, again, it's easier to compute with on your CAS. One of the first things I taught you was define. So if you've forgotten that, it's menu, actions. So actions, number 1, and then define number 1. So if you press menu 1, 1, that's your shortcut to getting define. And you literally type the equation you see. So here we go, we do f bracket x, close brackets. So
wait, so menu 1, 1?
Yeah, menu 1, 1 is a shortcut to getting define. Menu 1, 1, type in f, brackets over here next to the zeros, x, close brackets, and then equals. Equals is next to the trig, and you type in what you see. So 2, make sure to put the times x plus 5. I believe in the latest update, unless you haven't updated it, if you don't put it in later on when you start solving, it will not compute. You have to put that times in. It's practicing so that you know 2x actually means 2 times x. That's why you have to do it now. So 2x plus 5, press enter. So what's the question asking here? When they say f of 2, that 2 is a replacement for x. So essentially they're saying sub 2, x equals 2 into the equation. So normally what you would have to do is you'd have to say f of 2 just means sub x equals 2, so it'll be 2 times 2 plus 5. Add, and when they say f of 3, it just means sub 3 in. So that means it'll be 2 times 3 plus 5. Now you can do all of that manually, but you can also do it on your CAS. That's all you have to do. Type f bracket 2, that means sub 2 into the equation, plus f bracket 3, and that means sub 3 into the equation. Yep. Oh, that's true. Yeah. So when I press enter, it gives me 20. But again, you can calculate that manually as well. 2 times 2 is 4. 4 plus 5 gives you 9. This one is 2 times 3, which is 6. 6 plus 5 is 11. So 9 plus 11 does give you 20. But that's if you were to do it by hand. So that's just a notation to say sub x equals to 2 into this equation, sub x equals 3 into this equation. So when you say f of a plus 2, what does that mean? Just for those, maybe I'll just switch back and forth. Is that easier for you guys to read? Yeah? So when this says f of a plus 2, it just means sub x equals a plus 2 into the equation. Again, you can just type f bracket a plus 2, and it does it for you. But if you were to do it manually, this is what it looks like. Your equation would have been 2 times a plus 2 plus 5. So if you expand the brackets, 2 times a is 2a, 2 times 2 is 4. That's why you get 2a plus 9. Okay, so one of the benefits is just learning to use function notation. That's why you want to define on your calculator, define it first, and then you can do all these other tricks to it. Yeah. That means you've done some. Oh, it's probably related to. Yeah, I need to tell you this. When you start new problem, you should. Otherwise, it's linked to. It's probably thinking you're talking about. So I would teach you guys to do this chart. What do you want to do?
Bro, why does he say it like that?
Oh my god. Then we can make slot. Yeah, so we will look up.
Bro, you know what I hate? When like your CAS randomly turns on and then it's like it's like in your
Right, team, let's move on to the next little tip. Next question. Let's say we will do. I mean, you can do this one too.
I can draw blocks.
All right.
Oh, I forgot.
Question 2.
So are there going to be inequalities on the exam?
Yeah, because there's discriminants.
Oh my god.
Yeah.
Oh,
But you got a CAS. Well, it's better if you understood the theory, but yes.
yeah, I have no idea what the theory is for inequalities. Is it like the reverse?
All right, maybe I'll explain as we're doing this too then. All right, let's do question 2. Question 2, essentially, thank you, listening. We're sketching this graph. X plus 2 times X minus 2. Now, some of us can visualize it, some of us can't, but you got a CAS. Type it in, but this is what I want you to do. I'm going to give you a tip on your CAS. You see how we've got our function here is defined as... Sorry, why is all this coming up? I don't know why. Okay. You see how you got this function? If you went menu 1 and use F again, it's going to override this problem. For the short time being, it's okay. But when you want to go back and then check your answers, the problem is once you override it, all the work that you do before, you have to redo again. So one of the tips that I'm teaching my year 12s is that when you do a new question, insert a new problem. Not a new page, but a new problem. So what this means is you still retain f of x as this equation. But if you go to document, so click on document, go to insert, which is number 4. So document 4, and it says problem at the top there. I now add in a calculator, but notice the top, it's labeled 2. That's a way to remind you that you're now doing question 2. Yeah, doc 4.1.
So it's grayed out on mine. The insert.
Something's wrong. Did you start new page?
Oh, new.
Oh, you're in Scratchpad. Not meant to be in Scratchpad. Don't be in Scratchpad. We always use calculator. Scratchpad is literally like a quick calculation. If you're actually doing calculations, never use Scratchpad. We never do that unless it's in your own time. You're just doing your budget, taxes, whatever. Scratchpad is okay. For our maths purposes, always use the calculator page. Okay? All right. So calculator page. Notice now I'm in this page here. So again, menu 1.1. It's defined, but notice when I type f of x, see how it's not bolded?
Sir,
Yeah.
Does it redefine f or does it redefine x?
It redefines, well, this one defines f, but because I'm doing a new problem, f is brand new. There's nothing associated to it.
So it's the letter before and not the letter in the brackets.
The letter in the brackets means what does the equation have? Is it in terms of t, x? But in our case, always keep it as x, because if you want to sketch the graph only sketches if it's in terms of x. Yes, that's right. All right, so as you can see here, if I type F, notice that the F is bolded. That means that you've already associated F with something. Notice in my second page, when I added a new problem, F is not bolded, meaning it's brand new. You can still use that letter. So here, if I wrote f of x is equal to, and our question was, what was it again? X plus 2, x minus 2. So x plus 2, bracket x minus 2. See, this is now interesting. See, if I do f of 2, that just means I'm substituting 2 into the equation. So it'll be 2 plus 2 times 2 minus 2. 2 minus 2 is 0, so 0 times anything is 0. Whereas on this page, if I did f of 2, see how they're different? Because they're different sets of questions. Question 1, I typed the exact same thing. I wrote f of 2, but I get 9 for this one. Because they're doing 2, sub that into this equation. But in this page, when I did f of 2, they sub 2 into this equation. So that way, each question that you do, they're all separate. Otherwise, if you do it all on one page, it just keeps overriding the previous equation. And every time you want to go back and check, you're redefining everything again. So one of the tips I'm giving to you is to separate the questions so that when you go back and proofread, it's quicker to proofread. Especially if you're sketching stuff in question 1, and then you go to question 2, there's a different graph. So then you want a separate graph from the first one. Then you don't have to type it again. Okay? So get into the habit of using doc, insert, problem. I say do that for each question, new question. So question 1, keep all the questions 1, A, B, C, D, E, F in the one area. And then when you do question 2, keep it all in question 2, A, B, C, D, E. That just keeps your CAS more organized. Okay? All right, so what's the question we're working with? We are trying to find this equation. When is it less than or equal to 0? So let's visualize this. I've already defined the graph. Let's add a page to actually visualize it. So here we go, Control, Doc, which means add a page. I'm going to add a graph. And because I already defined it as f of x, I just type f of x. And that will be the graph for x plus 2 times x minus 2. That's the graph. What we're asking is, when will this graph be less than or equal to 0? Meaning, when will this equation have a y value of 0 or less? On the graph, I can clearly see it's this bottom half. Because this when it's 0, that's the x-axis. Less than or equal to 0 must be this region. I need to know what those 2 points are because I need to know what x values will guarantee I will have a y value less than or equal to 0. You know. Yes. And it's important because if you had 3 different equations and you use y for all of them, it's hard to figure out, well, which one are you talking about? That's why we use the front letter. So you can use F, G, or H to represent 3 different equations. Yeah? All right. Oh, welcome, Jen. All right, Jaden, we are working on this sheet. Just grab this sheet for now. Yeah. Grab this sheet for now. You need your CAS as well. All right, let's answer the question. So I need to know where those intercepts are, and I taught you, you can find it through the calculator page here, or you can do it on the graph. Okay, sure. All right, here we go. To find x-intercepts, how do you normally find x-intercepts again? What do you have to do? The y equal to 0. So normally, if this was your equation, x-intercepts occur when y is equal to 0. So it looks like this. This is what you're going to solve, right? But you can do that on a CAS calculator because this here was already defined as f of x. So you're really trying to solve for when does f of x equal to 0. So I literally will then enter in my calculator. This is your second key function. So you had define. The other one is solve. Here we go. Menu, algebra. So menu 3, 1. Menu 3, 1. The other one was menu 1, 1. Yeah, so menu 1, 1 is defined. Menu 3, 1 is solve. And here we go. What are we trying to solve? We're trying to solve for f of x equals 0. Because that's what we literally were just saying just now. We're saying let y equal to 0. And this is my equation. But since we're ready to find as f of x, so I'm really just solving for when does f of x equal 0. Now the calculator doesn't know what we're trying to solve for, so you have to tell them. We're trying to say solve for x. So you have to do comma. Comma is found on the bottom next to the O. Comma, x. And this will solve for your x values, which is your x-intercept. Here we go. Press enter, and we get -2 and 2. Mathematically, it made sense because if you use null factor law in this step here, you would have got your answer that something times something has to equal to 0. So one of them is 0, so x plus 2 could equal to 0. Solving for that, you get -2. This one could equal to 0. If you add 2 on both sides, you get 2. So mathematically, yes, that is true. But I'm teaching you how to use a CAS. Yeah? So I defined, then I solved for when the y function or the function itself equals to 0, means sub y equals to 0, solve for x. I get my x-intercepts. The alternative way is if you didn't do it through the calculator, you could have done it through the graph as well. Menu. Everything is done in analyze. So menu 6, this is in the graph page. 0, the very first one. So menu 6, 1. And this is how you use it. When you click on it, it comes up with this like dotted line. Wherever you think the x-intercept is, you pick to the left of it, and then you pick to the right of it. So here, I know the x-intercept's roughly here. So I'm just going to click over here to the left of it, click once. Then I drag my cursor across until I pass it, and I click twice. And it tells me that point is negative 2, 0. I do the same thing again.
So does it work for the y-intercept as well?
No.
Okay.
But there is another thing that I know students do. I don't do it because y-intercept, I just simply go back here and I just do f sub x equals 0 in. And it's negative 4. Because to find y-intercept, you let x equal to 0. So that's what I did. So this is how I normally find my y-intercept.
And for that one, you don't need to solve.
You don't need to solve because I'm just subbing in. Solving is when you're actually manipulating the equation. So that's how I would do it. How students normally do it though, to find the y-intercept, students go to menu, and I don't normally teach this one, but you guys can use it. It's called trace. So menu number 5, trace, and graph trace. What's nice about graph trace for the amateurs is that when you move left and right, it'll kind of magnetically stick to key points. So you see how if I'm moving to the y-axis, it naturally touches and it tells you y-intercept is 0, negative 4. So if you press enter, it just puts a point there. And then
Wait, so what was the...
that one was menu trace.
No, the other one.
Before that,
So menu 5-1.
oh, 0.
Menu 6 0.
Oh, menu 6-1.
Menu 6 1 and then menu 6 1 0.
Oh, no. So it's called 0.
Oh,
The number, so you do menu and then press number 6 and then press number 1.
It's like menu 1 0.
Yeah. So menu 6-1 will get you the way to find x-intercepts. So that's right. I'll do an example again. So here,
That one was f equals 0.
f of 0 will give you the y-intercept. Yeah. So if I do this one now, same thing again. If we want to find x-intercept, say I know it's roughly over here. Use your cursor, click once to the left of it, anywhere to the left of it, and then drag your cursor anywhere to the right of it and click once.
So menu 5-1.
And like see get the sort of input.
Or that will get the x-intercept. Whereas if you use graph trace, so menu 5, 1, menu 5-1 will magnetically attach itself to key points. So we go to menu 5-1 again. See, if I just move left and right on your cursor, if you just move left and right on the arrows, it will naturally just stick to itself where there are key points. And that's the same for turning points and all that. Why do I not like teaching this? Because when you get to year 12, the graphs aren't that small. They're in the millions and thousands. And if you go left, right, you're going like by 10s, 20s, it will take forever to get to the points that you want.
Is there a way to make bigger jumps or like straight to the finish line?
No. That's why the kids, I see them doing it. They're like clicking and it's running across. It goes up, goes down, goes up, and it goes across. And I'm like, oh my God, all you have to do is you could just go on here, solve an equation, simultaneous it, but no, they learn this graph trace and they just stick to it. So that's why I don't like teaching it. But for your sort of your stages at the moment, most of your graphs are pretty nice numbers, so you can probably use graph trace. I don't like it though.
Where my CAS calculator is.
All right, once you've done that, you want to get out of graph trace. Notice on the top that means graph trace. Press escape so that you're out of that function. So every function that you do, just make sure the top corner doesn't have an icon. Press escape. That's how you get out of it. And that's our graph. Now to answer the question's asking, when is this graph less than or equal to 0? So I'm just going to go back to OneNote to explain what we're actually doing here. We're asking, when is x minus 2, x plus 2 less than or equal to 0? This is your graph. 0 is this line. Less than or equal to 0 must be this region. So, how do I get these coordinates? Means I have to select numbers between, and this is the x-axis, so it's between -2 and 2. So if I had to answer that question, the answer is, when will this function be less than or equal to 0? It's when x is from -2 to 2. Now, if that notation is confusing, you can also write it like this. x is greater than or equal to -2 to +2. Okay, so this is the interval notation. Also, inequality notation.
Is that like a reverse?
Yep, that's the element symbol, epsilon. So it's a backwards 3 to mean x is a part of, and then square brackets because it includes -2, all the way to it includes +2. Either notation's fine. This is called set notation. Set notation. All right. Let's have a look. Let's do another question where you're practicing to sketch and find points. Let's do... Which one can we do? We'll do...
What is that? What is that, sir?
All right, baby. All right. Let's go find something else.
There's not going to be links.
No.
If it's not on the exam, why are you showing us?
I'm teaching you CAS. I'm not really teaching you the...
It's just relevant.
All right, this one then. Question 3. That's relevant. All right. Same thing on your CAS. I want you to add a new problem because we're on question 3 now. Question 3, to add a new problem, how do we do it again?
Menu 4-1.
Close. Document,
Document 4-1, yeah.
insert, so number 4, so doc 4-1, add a problem. We're going to go to number 3 now, so let's add a calculator. So I'm on 3.1 now. I'm on question 3. I'm going to get you to define this function. Do question 3, I want you to practice yourselves. Menu 1-1, define this function. Let's go. -3x squared plus 4x minus 2. So we go, menu 1-1, define f of x. And notice it's not bolded. It's all fresh again. -3x squared plus, whoops, I forgot the times x squared plus 4 times x minus 2. Let's practice. Let's see. I want you to solve for the x-intercepts on this page. I don't want you to go to the graph page. How do you find the x-intercepts? You go solve. Good. What do you solve for?
F of x equals 0, x.
Very good, because you want the y value to equal to 0. So here, what's the shortcut for solve again? Menu 3-1. Menu, algebra, solve. Menu 3-1. If I want to find the x-intercepts of this graph here, it's when f of x, which is the y values, equals 0, comma x, to say that I'm solving for the x values. So what does this mean? It means you haven't done anything wrong. It just means there's no x-intercepts. So...
The discriminant is higher than 0, lower. I've got this in my note sheet somewhere.
Good. Check your notes and learn that again. So we don't have an x-intercept. Doesn't touch the x-axis. Find the y-axis intercept. How do you find y-axis intercept again? Shh. Quiet down. How do you find the y-axis intercept again? What do? F0. Very good. You're substituting x equals 0 in. And it tells us it's -2. So far, this is what we've got. We know this graph could either be a smiley face or a frown. We know it doesn't touch the x-axis, so it could be above or it could be below the x-axis. But we do know that the y-intercept can't be this one at the moment because it has to cross 0, -2. So I already know the y-intercept's here. And it's a frowny face because, what's another hint? Very good. The coefficient of x squared is -3, so I know it's a frown. So we now know it's something like this, or maybe it looks like this. We don't know where the turning point is. So here's the other thing I taught you guys. Turning points. You can change this to a turning point form by completing the square. Now you can complete the square by hand, or you can complete the square with a CAS. So complete the square. Let's do it with the CAS.
Can you go a bit slower?
Go to, menu. Algebra. Shh. Listening. Thank you. I'm teaching you how to complete the square with your CAS. So here we go. Menu. Algebra. And notice completing the square is part of the option. There's number 5. So menu 3.5 will allow you to complete the square. So if you go to complete the square, what do you type there? Normally you type the equation, but you don't have to now because you defined it. So you just type f bracket x, comma x, so that they know you're factorizing in terms of x. Press enter.
Wait, so what was the thing for completing a square?
Menu algebra, menu 3, 5. Menu 3, 5. So have a look at what I wrote there. We found out there's no x-intercepts. We found y-intercept is a -2.
How do I change it back to the fraction thing again?
Oh, if you're getting decimals. Good question. Now, if you want exact values, make sure your settings is not on auto. So this is what you do. Go to document. Number 7 is settings. Document settings. So number 2. So if you do menu 7.2.
Wait, menu 7.2?
Yep.
Okay.
Notice that my calculation mode is in exact. Mine's not on auto. It's not on approximate. Change it to exact. And then press OK.
Yeah.
Change it to exact and press OK. That's the number of digits.
So document
Can you
settings.
send them to your laptop and print it up?
Greater than 6. 8 is a good number for students. 12 is because I write sacks. So you don't need 12. But
Sorry, can you
greater
say-
than 6 is good.
So can you say it again, but let me know for how to make sure it's not in decimals.
Oh, yep. So, listening.
Actually find everything.
You nines. Thanks.
When you ask the question.
Thanks, you nines. Thanks. Just withhold your conversations because as I'm guiding through this, a lot of it, as you're learning your CAS, I will be repeating, which is okay, but I do want you to be listening and trying as well because it's hard to learn CAS if you haven't been practicing it. Yeah? So, to check that your settings is in exact values, it's in document, so click on document. Settings, number 7. And then number 2, document settings. A good question from Mira was, why is mine on float 12? That's because I write the SACs and exams for the year 12s and 11s. I need to take as many digits as I can, so I go up to 12. For you guys, just make sure it's above 6, especially when you get to probability. Greater than 6 is better for you. My advice to students normally is to get 8. So just have 8 and then you should cover your bases for most things. Okay? And then the next one, check your calculation mode. If you're doing methods, then your angle should be in radians. But if you're unsure what you're doing, then just leave it as degrees, right? Because we haven't done circular functions yet. But radians is another setting to double check. You can keep it on auto. I'm just saying that the reason why mine doesn't come up with decimals and it comes in fractions is because I have it on exact. So that part there, if it's on auto, sometimes it comes as decimals. I like it all in fractions because year 12 methods, that's how we write our answers. Okay? Yes, you know.
When you said like 6, decimal places, like numbers in total.
No digits. The problem is that when you go into year 12, some answers could be like 2,732. And then if they say, sorry, that's 27,232. But if they ask you to round to 4 decimal places now, you see, you're running the risk that if it was 4 decimal places, that's 1, 2, 3, 4, 5, 6, and you're stopped. Like you're stuck there. So 7, 8, 9, that's why I go up to 12. But it's rare that you get this kind of answer, and it's rare that you get thousands and 4 decimal places. The only time 4 decimal places comes up is when you're doing probability, and if it's probability, you never get 27,000. That's why it's safe to stick on 6 or 8 as your float. 6 or 8 as your float number of digits is safe. Safer. Yeah. All right, let's go back. So completing the square, you got that one there. So if you know how to do it by hand, you can test it. Otherwise, it's by CAS. You should get -3 bracket x minus 2/3 squared minus 2/3. Let's see what you remember. There's a reason why this is called the turning point form. What's the turning point? 2/3? Negative 2/3. Very good. Remember, this tells you up or down. Since it's negative, it's down. Down 2/3. And then I said, whatever you're squaring, let it equal to 0 and solve for x. And you can see that x will equal to 2/3. That's why I know it's positive 2/3. So it moves to the right by 2/3 and it goes down by 2/3. So right 2/3, down 2/3. So where's your turning point? 2/3 is roughly over here and down 2/3. So something like this. That's what the graph would roughly look like. 2/3, negative 2/3.
So this one's my left hand, so that one's your left hand. The one that's on the other side. Yes. No, the other one, the other one that's right.
Just remember positive something.
Let me just find another problem. And applicate. Oh, this one is a good one.
How did I get 32?
Wait.
All right. Sorry, I just want to double check. Yep, it's all good. We're going to do question number 1 in section B. All right, can everyone turn to section B, question 1? Should look like this. Let's practice an application where you're using your CAS, tying it all together. You're going to sketch it, you're going to solve and answer the questions. Yeah, change the T to X. All right, here we go. Add another problem. This is a new question now, so add another problem. So here we go. Document. Insert. Problem. So I'm on now number 4, add a calculator. So 4 now represents your extended response. Section B, question 1. Let's practice again. Here's your question. A ball is thrown vertically upwards. Its height is given by this formula. T is measured in seconds. Define that function for me. Let's go. Menu 1-1. Define. You can call it whatever you want. I'm going to call it h of x. Or you can do f of x. Doesn't actually matter. Equals. So h represents height. It's 75 times. Now notice I'm not using the letter T. Why am I not using the letter T? Good. If you're sketching this on your CAS, it has to be an X. If you put T, it won't sketch. Here we go. Minus 6.5 T. We good? Defined? All right. So in the previous, thank you. In the previous problem, I showed you how we did it on the calculator page. So I found x-intercept, y-intercept, and then a turning point form to find the turning point. This time, I'm using the graph page that you could do the same thing as well. So here we go. We've defined it. Go control, doc to add a page, add on a graph. So number 2. We've defined it. I called it h of x. You might have called it f of x. Doesn't matter. I type in h of x. Now we're going to practice to edit this graph because I can't see it.
Oh, it's the menu for
Good.
Windows settings.
Windows settings. Good. That's the one I normally tell you guys to do first. So zoom fit. That is the automatic version. Sometimes it works well. Sometimes it doesn't. Probably 80% of the time it doesn't. So I go to zoom fit first to see if it can fit the graph. And it's not too bad. It's not too bad. I just need it to be a bit more to the right. Now remember, you can actually shift with your cursor. You can actually move it across. Move your cursor to a page. And then hold on to the pad. Hold on to the mouse pad until there is a hand that comes up. So it should look something like this. Oh, where's the hand? I can't do it on my screen. But if you hold on to it for a few seconds, it should have a little hand that comes up. And you should then be able to shift. Oh yeah, there it is. It should look like that. And then you can actually move a bit left to the right. Okay, so use your mouse, put on anywhere on the page, then press onto the mouse pad for a few seconds. And then once it's in a few seconds, there should be a hand that comes up that holds it, and it kind of looks like that. Then you turn the mouse left and right, and it should move left and right. Move it closer.
Zoom in. It's a bit small as well.
Oh, yeah, good. So adjust it to where you want, and then click once. Good. So once you've adjusted, now how do you zoom in? I taught you another one. Menu 4, box. Very good. Zoom box is the second one I taught you. This one you make a box where you want, so click on a corner. So I can click here once. Then it move the cursor and it shows you where you want to go up to, like this. And click twice. And that's a beautiful graph.
Oh my days.
I'll do it again. So go to menu 4, zoom box. So once you've got the graph in your actual page, to make it look closer, don't do zoom in, use zoom box. Click one corner once, and then move your cursor somewhere else to find another corner where you want the box to be. And it automatically will adjust it to when that's better zoom in than any other zoom ins.
How do you turn your cursor back to normal after you...
So that corner there, that means you're still in that mode. Press escape to get out of it. So if you press escape once, now it's back to a normal cursor.
Mine has a bunch of numbers on it. How do I remove those?
Ooh. Oh. I think that's potentially in your settings. So go menu. And then go to number 9 for settings. And it might be... Oh, maybe you can... Did you have show axes and end values? Because if you just take that one off, then it won't be there.
Oh, sir, when I did the exclusive thing, where you like select the area, and it said,
That's good ones. That's what I want to teach as well. All right. You know, this is an important one. If you followed my instructions up to this point and you got the graph here, here's another one that I was actually going to teach you guys, but it's good that someone's tried it. When you find the x-intercepts, so I taught you before, menu, analyze, and then 0. Yeah, so menu 6, 1. Now notice when I find this x-intercept on this side, so I click once to the left of it, I click twice to the right of it. Can you see how it comes up with this e negative 11? This means 10 to the power of negative 11, which means it's a very small decimal. But the reason why it can't capture every decimal, why it doesn't start off with 0 point something, is because of your graph settings. So my year 12s, if I see this on their CAS, it means that they haven't ever done any graph settings or any practice on these type of questions. Fix it once, and then your CAS doesn't ever have that problem again. So this is how you fix it. Go to menu. Number 9. So this is different settings. This is actually for your graph settings. The other one was calculator settings. So graph settings, go to settings. See that float? that means you're asking the calculator to only show 2 digits. Most times it's more than 2 digits. So go to about 6. 6 and above will be safe. So you change that to 6. See if I press OK now. See how I see more digits? That way, you're safer. So that just means it's negative 5.8207 times 10 to the power of negative 11. That means that you must do more. Yeah.
But what does the E mean? Wait, is it like... Why is it not 0?
Because negative 11 is just so many digits. So if you want, you have to show float even more.
Why is it not 0?
Because it's not enough digits. Because I wrote 6 digits. So 1, 2, 3, 4, 5, 6. If you want more digits, which we need another 11 digits in total. There's another way to do this as well. Listening?
Because the x-intercept to y equals 0. That's the thing, right?
Oh yeah, it should just be 0.
Yeah.
Oh, that's just stupid. I just realized that should just be 0. It should just be 0. Well, good thing. Well, that's the x-intercept. So the y value should be 0. Well, it should be. I just realized. That's true. No, it should be 0. But at least now you know how to change that decimal. But there is another shortcut. Listening. If you want to as well, move your cursor to that digit, so that coordinate, so that's the y coordinate, and you just press plus. So if I press plus on it now, it adds another digit. And if I press plus again, it adds another digit. If I press plus again, it adds another digit. So if I keep pressing plus, it will keep adding digits. Okay, so just move the cursor to coordinate and then press plus.
Wait, why is it negative?
Is that what E and the thing means? That there's like a bunch of zeros?
No, but
E
why-
means 10 to the power of.
Why is the coordinate?
Is that like...
Why is the x coordinate? No, why is the
like
y
that last
coordinate of the?
semester?
Yeah, scientific notation. 10 to the power of negative something goes to the left, 10 to the power of 2 or 3 goes to the right. So for example, if I wanted to write 0.021, that is the same thing as saying 2.1 times 10 to the power of negative 2.
Oh, and that's what is that what the decimal before?
Yeah, so before on your calculator it will say something like this,
Oh.
like that. Instead of saying 10,
Oh, so that's why it's like a bunch of zeros now. Oh.
alright team!
That makes much more sense.
Eyes and ears towards the board. Here we go. So, you know how to find x-intercepts already? So it's menu 6-1. We already know that's 0, 0 there. Need to find the maximum, which is a turning point. So you can do it again. Menu 6, maximum. If it's a minimum graph, then you use minimum. But in this case, we're looking for the maximum. So menu 6-3, again. Estimate where the maximum is. Click to the left of the maximum once. Click to the right of the maximum twice.
Wait, so why wasn't the 0 like in that?
This one.
Yeah, why wasn't it just 0?
Because before I had, let me put a minus to it. So I had,
Because if it's just the x-intercept, then shouldn't it just be
yeah, it should be. Whatever the algorithm didn't come up that way.
question? Like, that's like the question or the calculation?
That's a calculator. All right. I'm just going to wrap it up because I think at this point, thanks, U9s. I'm going to wrap it up here because I'm getting a sense that some of you are knowing your CAS already and some of you don't. Then I'll come around and help individually. One last thing to note. Still waiting. Last thing to note is, see, there are 2 ways to find your turning point. One was through the calculator. One is through the graph. Graphing is nice because you can visualize and see what you want. Problem with it is it will give you decimals. You can't get exact values through your graph page. So if I don't ask for decimal places, if I don't say round it and you give me these values, I will not give you marks because I didn't ask for decimal points in your graph. So if I want exact values, then you should go back to the calculator page and find the turning point through your calculator page. So that's why we have two different settings. One for graphing and one for calculator.
Can
Okay?
you turn on the exact value in your graph as well? And if you do it, it'll spit out like really wacky outputs.
You can't. There's just no setting for it. Yeah. All right, so that's it. I think that should give you most of it. So then you should then be able to answer the questions as you go. Okay, I'm going to stop the video there.